Alright, so I wanted to start off today just doing a couple of problems that aren't in the handout just to illustrate the similarities and differences between sections 2.4 and 2.5, because those are the problems where we kind of have common denominators and you're adding and subtracting fractions, but they're real different, and you have to be able to distinguish the techniques to solve each, because you can't do the same thing for each because it won't take you to the right answer. So I'm just going to randomly make up some problems and solve them both. So that would be something that would be a possible test question that would be similar to something we did in section 2.4. And I'm also going to make up a problem and eventually do it that would be similar to something we do in 2.5. So the big difference between the two problems is this equal sign, and the equal sign will make me get a different kind of answer and make my algebra different. For both problems, the first thing I'm going to do is factor. Anytime I have a fraction that has a denominator that's factorable, factoring it is never going to be a bad thing to do. So I'm going to factor both denominators for the first problem and solve this first problem out completely, including checking. And then I'll do the second problem and try to show you the big difference. So this denominator, again, it's moderately hard factoring, not that hard. There's no minus signs, so I don't have to worry about putting any minus signs. There's no number in front of the x squared, so I don't have to worry about bottoms up factoring. I just need to get numbers after the plus signs that have to multiply to 8 and add to 6, and 2 and 4 will do that perfectly. So this left denominator I'm changing to x plus 2 times x plus 4. The right denominator, same deal, I'm going to factor it. I'm going to make two parentheses. There's no minus signs in the right denominator, so when I do the factoring, I don't have to worry about minus signs. My last have to multiply to 6 and add to 5, and 2 and 3 will do that perfectly. If I was doing this problem, I would have factored this denominator on my first step. That's kind of the only similarity between the algebra when you're adding and when you're solving an equation. In this left panel here that I don't have an equal sign, I have to make each denominator the same by multiplying numerator and the denominator by what it's missing. So if I continue doing this one, the first fraction is missing this x plus 3, so I'm going to give it the x plus 3, and because the problem doesn't have an equal sign, I have to give it that x plus 3 in both the numerator and the denominator. The second fraction is missing the x plus 4. And similarly, I need to give it to both the numerator and the denominator. And that's going to be real different than what I do when I solve the second problem. So now I've made each fraction have the three pieces, x plus 2, x plus 4, and x plus 3 in their denominators. I'm going to multiply out the numerators. I'm not going to worry about this negative sign just yet. So this first numerator I have to FOIL. And when I FOIL that numerator, the firsts are going to be x times x, which is going to be an x squared. The outers are going to be x times 3, which is going to be a positive 3x. The inners are going to be 1 times x, which is going to be a positive 1x. And the lasts are going to be 1 times 3, which is a positive 3. Positive 3. So for this numerator, I'm going to rewrite it as x squared plus 4x plus 3. That's what I get when I FOILed out the numerator and combined the outers and the inners. And I'm going to leave the denominator in the order that I have it, x plus 2, x plus 4, x plus 3, but it probably would look nicer if I did x plus 2, x plus 3, x plus 4. The order that you write the parentheses in the denominator doesn't matter. Second fraction, I'm not worried about the negative yet. I'm going to clear the parentheses. I'm going to go minus 3. I'm going to go 3 times x and 3 times 4. If I deal with the minus now, I'm probably going to make a mistake, so I'm going to hold off on dealing with the minus. So 3 times x is 3x, 3 times 4 is 12. Because I committed to an order for this denominator, I'm going to write this denominator in the same order. You can shuffle the parentheses around, and it doesn't change what the fraction equals to, and your order doesn't have to be the same as mine. Now I have the two fractions written with the same denominator. I can't clear the fractions because there isn't an equal sign, but I certainly can make the two fractions into one right now. So I'm going to take the numerators and combine them together and write it over just one copy of the denominator. This minus sign is going to cause that sign to switch. It's also going to attach to that minus 3x. So when I make the second numerator part of the fraction, I need a minus 3x and a minus 12. And whatever order you decide on the denominator you need, I'll just stick with it. I'm almost done. I just need to combine like terms in the numerator. The like terms in the numerator are 4x minus 3x and plus 3 and minus 12. So I'm going to simplify this numerator. I'm going to leave the x squared alone. 4x minus 3x is 1x. I don't need to write the 1, but it's okay to write the 1. 3 minus 12 is 9. With 3 pieces of my denominator, I can shuffle the order, but they're not going to change, and I'm never FOIL out these denominators. I'd like to attempt to factor that numerator, but that numerator is going to be prime, because in order for this to factor, I would have to have two numbers that multiply to 9 that subtract to 1, and the only numbers that multiply to 9 are 1 and 9, which subtract to 8, and 3, which subtract to 0. So there aren't any lasts that do what they need to do. So this is the answer that I think is correct. And I should absolutely check that, because there's a chance that I've made a mistake that I didn't realize that I made. So for checking, we generally pick a number and plug it into the original problem, and we plug it into the answer. I'm going to plug 2 in to the original problem and my answer and see where that takes me. So plugging 2 into the original problem, I'll go 2 plus 1. I don't really need the parentheses when I do the 2 squared, but it's not wrong to. If the 2 was negative, I'd have to have a parentheses there. If I didn't have a calculator that made this easy, I probably would never even check these. So that's one thing I need to do, is take 2 and plug it into the original problem. So let me just go ahead and do that so I have my calculator handy. So fraction 2 plus 1 over 2 squared plus 6 times 2 plus 8 plus, delete, minus fraction 3 over 2 squared plus 5 times 2 plus 6. So plugging 2 into the original problem, I get negative 1 over 40. The only way that I'm comfortable in the answer that I have written down here is if I get the same number when I plug 2 into my answer. So I'm going to come down to my answer and plug 2 in. I'm going to go 2 squared plus 1 times 2. I'm not going to write the 1 times 2, but you could write the 1. It's fine. 1 times 2 will just be 2 anyways. I didn't write the 1 in front of that 2. And then I'm going to get over 2 plus 2 times 2 plus 4 times 2 plus 3. And I hope like heck I get negative 1 over 40. Otherwise I made a mistake and I need to hunt it down. So fraction 2 squared plus 2 minus 9 over parentheses 2 plus 2 times 2 plus 4 times 2 plus 3. And, oh, beautiful. So because I got the same result of plugging 2 into the original problem as I did my answer, then I'm comfortable that my answer is likely correct. It's not 100% guaranteed that my answer is correct. You could make a math error and have plugging 2 into the original problem and plugging 2 into your answer, coincidentally work, but that's really, really unlikely. So I'm feeling good about this, and I'll say that part is done, and I'll move on to the second part. So the second part, the only thing that's similar is the first step in terms of the algebra. I'm going to factor the denominator that can be factored. And that's the denominator to the right of the equal sign. And usually on these problems with the equal signs, if a denominator can factor, it factors into the denominators that aren't factorable, and that's the case here. This factors, I know that I don't need bottoms up, so my first are going to be a couple of x's. My signs have to be plus and minus. My last have to multiply to 4, subtract to negative 3. They're going to be a plus 1 and a minus 4. So that step's the same. If there wasn't an equal sign, I'd make each denominator have an x plus 1 and an x minus 4. But there is an equal sign. I don't want to do that. I want to clear the fractions. So I'm going to multiply each fraction by what I'd make the fractions denominator into if I was adding or subtracting over 1. So I'm going to multiply by x plus 1 times x minus 4 over 1 each piece. So I'm going to multiply by x plus 1 times x minus 4. Not that that's really readable. My marker's, I'm failing my marker. But I multiplied by x plus 1 times x minus 4 over 1, x plus 1, x minus 4 over 1, x plus 1, x minus 4 over 1. Completely different. When you don't have an equal sign, what you multiply by is identical in the numerator and the denominator, and you make each fraction the same. The fraction doesn't go away, and your answers normally has both x in the numerator and the denominator. Doing this strategy, I'm going to cancel the fractions, and I can only do that when there's an equal sign. When I do the first canceling, I have a 2 over 1, because that x plus 1 cancels to a 1, and an x minus 4 over 1 being multiplied when I do that canceling. I'll multiply that out. I'll go 2 times x, which is 2x, 2 times minus 4, which is minus 8. I don't need to write a fraction because I only have a 1 in the denominator. Next piece, cancel the x minus 4s. They turn into 1s. So technically, I'm left with 3 over 1 times x plus 1 over 1. I'm leaving the x plus 1 in a parentheses because it's going to be necessary. I don't need the fractions, but I do need to do minus 3 times x plus 1. If I didn't have the parentheses, I might forget to multiply the minus 3 by the positive 1. I might forget either to multiply it or change the sign or both. So this should be 2x minus 8 minus 3x minus 3. Almost done with the hard part. To the right of the equal sign, both the x plus 1s and the x minus 4s cancel. Everything turns into 1, makes the fraction turn into 4x over 1, the initial fraction, and it makes what I multiplied by turn into 1 over 1. So this is a good thing. Now I'm going to cancel the fraction because I just have 1s in the denominator. Technically, I'm just left with 4x times 1, which is 4x. Now I have a problem that doesn't have fractions, so I don't have to worry about the fractions anymore. It doesn't have a square, so I don't need to worry about factoring. I do need to simplify the left and the right side. On the left side, I'm going to go 2x minus 3x. 2 minus 3 is negative 1, so that will give me a negative 1x. And I'll do negative 8 minus 3. Negative 8 minus 3 is going to be negative 11, because the numbers were both negative, so I added them and kept them negative. Now, because I'm not factoring, I need to get the numbers on one side, the letters on the other. So I'm going to add 1x to both sides. When I do that, I get negative 11 equals to 5x. Almost have my answer. I'm going to divide by 5 to get my answer. So I'm going to get negative 11 fifths equals x. That's really unpleasant to check even with my calculator, but I got to check it because I might have messed up. So I'm going to go back to the original problem. Checking for this is different than checking for that kind of problem. And the first problem, I had to check the original problem with a number that I completely made up, check the answer with a number I completely made up. This version, you have only one number that you have to check, and you only check it in one place. So when I go to check this, I'm going to go 2 over negative 11 fifths plus 1 minus 3 over negative 11 fifths minus 4, and see if that equals to 4 times negative 11 fifths over negative 11 fifths squared minus 3 times negative 11 fifths minus 4. If I didn't have my calculator, I'd never try to check this. I need to do the left side and the right side separately. So first I'm going to figure out what this equals to as a number. And it's not going to be fun, but it shouldn't be that hard. So fraction 2 over fraction negative 11 fifths plus 1. There's the first fraction entered reasonably well. Arrow out of that, minus fraction 3 over fraction minus 11 fifths minus 4. So that looks a heck of a lot like what I have written there. When I hit enter, that will tell me what the left side simplifies to. Simplifies to negative 110 over 93. The only way my answer is correct is if on the right hand side I also get that same number. Messy, but I should be able to do this. So working on the right hand side, fraction 4 times parentheses fraction negative 11 fifths parentheses over parentheses fraction negative 11 fifths parentheses squared minus 3 times parentheses fraction negative 11 fifths. I'm getting there, and then minus 4. So I feel good about what I've typed in. I won't feel so good if I don't get negative 110 over 93. Oh, beautiful. So it was a moderate nuisance to check, but it's just pressing buttons, and I can get pretty good with this calculator, so the pressing buttons didn't really intimidate me too much. So because when I plugged the answer into both sides of the original equation, it gave me the same number, then I know that my work is correct. So in terms of answers, when the problems are adding and subtracting and they don't have equal signs, you expect your answers not to be x equal to some number. You expect your answer to be a fraction with both x's in the numerator and the denominator. When you have adding and subtracting with fractions but you do have an equal sign, you expect your answer to be x equal to some number. When I don't have an equal sign, I'm multiplying the numerator and the denominator by the same thing, kind of by what they're missing. When I do have an equal sign, I'm multiplying by what I turned the denominators into over 1. So these problems are probably the hardest on the test for students in general. The stuff from the first couple sections, finding the domain, multiplying fractions, reducing fractions, dividing fractions, because you don't need least common denominators, you're not clearing fractions, they're just generally not as hard. If you're going to mess up, it's going to be jumbling these together somehow and doing the wrong thing. Probably the most common mistake is for students to treat this problem like that problem. Like if you started off this fraction multiplying this one by x minus 4 over x minus 4, multiplying this by x plus 1 over x plus 1, and not multiplying this by anything, then you'd get a line that, although it's correct, it's not very useful because it will still have fractions. Okay, let me dig into today's section, and at some point I'm going to go out of order, but not for the first few problems. So the first few problems, problems 2, problems 6, 4, 2, 4, and 6 are just cross-multiply problem. There's lots of ways to do these properly. So if you were working ahead on section 2.6 and you did problem 2 already, and your method for solving was different than mine, it doesn't really matter because there's many ways to get these answers. But for problems 1 through 6, and I don't know about 7 because I don't have the handout in front of me, I'm going to solve each one of these by cross-multiplying. And real specifically, I'm just going to take the numbers in the problems in the order that they're given, and I'm going to create fractions. So the first sentence says, out of 5 new cars that are selected, 2 of them had cosmetic imperfections. So I'm going to make a fraction. In the numerator, I'm going to put the 5 cars that were selected. In the denominator, I'm going to write the number that have imperfections. I'm putting words next to the numbers because when I go to do the second fraction, I need to know where to put the number. So I just took the first 2 numbers, attached meaning to those numbers, and formed a fraction. Now I'm making an equal sign, and to the right of the equal sign I'm going to form another fraction. There's only one number left in this problem, which means I only have one more number to put to the right of the equal sign, and I have to decide where to put it. And I have to decide if these 1,000 cars were just 1,000 cars that were selected, or if they were 1,000 cars that had imperfections. And as I read this, it says out of how many cars out of 1,000 will be expected to have cosmetic imperfections. So I'm assuming this 1,000 is 1,000 cars that were selected, and from these 1,000 cars I need to know how many of them have imperfections. So the unknown is the number of cars that will have imperfections. And I can do this in my head, but I won't. First of all, you should realize that my answer shouldn't be more than 1,000. If I'm selecting 1,000 cars, at worst, all of them have imperfections, but not more. I can't have more cars having imperfections than I select. So if you get an answer that's bigger than 1,000, I know I've messed up. If I get a negative number, I think I've also messed up, because the answer needs to be some number between 0 and 1,000. It can't have less than 0 cars having imperfections. I can't have more than 1,000 cars having imperfections. I'm going to solve this by cross-multiplying. I'm going to cross-multiply up and down. Doesn't matter when I cross-multiply which side I put each on. So I'm going to go 5 times x equals 2 times 1,000. When I do that, I get 5x equals to 2,000. I'm going to divide both sides by 5. You can pull out your calculator if you can't do that in your head. I get x equal 400 cars with imperfections. So of the 1,000 cars, that makes sense. That's 40% of them, and 2/5 is 40%. I expect 400 cars to have imperfections. If I want to check, I should go ahead and do that. So if I want to check to make sure my number at least fits, it should be the case that if I take the number 400 that I think is my answer and plug it in for this x, it should be the case of both sides reduced to the same number. 5 over 2 is a reduced fraction. Let me reduce the fraction 1,000 over 400. It also reduces to 5 halves. Because when I plugged the answer in for x into the original problem, because both sides simplified to the same number, at least my solution for the equation is right. If I set my equation up wrong, then I could get an answer that checks it's still not the right answer. But this verifies I haven't made an algebra mistake. It doesn't verify that I set the equation up right. Okay, 4 and 6, I'm also going to cross multiply. So I go to the first sentence and I see numbers. And I'm going to create a fraction with those two numbers. Very specifically, it says 1 out of every 4 Scratchers tickets is a winner. So the 1 stands for the number of winners, or the number of winning tickets. The 4 stands for the total number of tickets purchased. So 1 out of every 4 is a winner. So I'm going to form a fraction. In the numerator, I'm going to put the number 1, and the number 4 will go in the denominator. I'll do that for each of the first 6 problems. I'm just going to form a fraction with the numbers given in the first sentence. In the second sentence, there's only one more number. I'm going to write a fraction to the right of the equal sign, and I need to decide where to put that 20. I have to decide if that 20 stands for the 20 winning tickets or 20 tickets purchased, and put it at the right level of the fraction. Because if you put it at the wrong level of the fraction, you'll get the wrong answer. And these 20 tickets, I want to know how many of them are winning tickets. So they're just 20 tickets that were purchased. And of those 20, I want to know how many are winners. And I'm going to put that as my unknown. X is going to be my number of winning tickets out of 20. And I could do that again without doing any algebra. But some problems are more complex and you can't. So for this problem, I would never do this algebra. I'd probably write down the answer, because I can write down the answer of 5 without really even thinking about what my mind is doing. So I cross multiplied. When I cross multiply, that gives me 4x equal to 20. Divide both sides by 4, you get 5 winning tickets. So x equal to 5. So if you buy 20 tickets, you'd expect on average for 5 of them to be winners. That's not a guarantee, but because you can mean all 20 could be winners, none can be winners. But on average, if you did that enough times, every time you bought 20 tickets, sometimes you'd win more than 5 times, sometimes you'd win less than 5 times, but on average you'd win 5 times. And I can see that that checks. If you put 5 in for the x and you wanted to check, you'd go 1 over 4 equals 5 over 20. 5 over 20 reduces to 1/4. I can do that without this calculator. And it checks just perfectly. So last of the really kind problems, and then I'm going to go out of order. So immediately I see the first sentence has 2 numbers. The numbers in the first sentence tell me 1 of every 13 people have red hair. So I know I'm going to make a fraction that has 1 over 13. I have to decide what words to give these numbers. And I think it's 1 person with red hair. So the 1 stands for the number of people with red hair. The 13 stands for just the total number of total people that I don't know their specific color. Even if you get 1 of the numbers named, it'll be enough. Next sentence, how many people in a group of 200 people are expected to have red hair? So that 200 people, it doesn't stand for 200 redheads, it just stands for 200 generic people. So that number doesn't belong in the numerator because the number that goes in the numerator is the number of people with red hair. In the numerator, that's going to be the unknown. X is going to be the number of people with red hair. And I was told I have to round to the nearest person, which probably tells me my answer is going to be a decimal, and it doesn't make sense to have a decimal number of people, so I said to round. So I'm going to cross multiply again. I'm going to get 13 times x equals 1 times 200. This is going to give me 13x equals to 200. This calculator doesn't like to give decimal answers, so I'm going to have to force my calculator to coax a decimal out of it. So when I go to enter 200 over 13 on this calculator, I bet it's just going to give me 200 over 13. So I'll go 200 over 13. I hit equals, and that's not that great for an answer because I'm hinted that I want to round to the nearest person. I want a whole number, not a fraction. On your calculator, if you get a fraction answer and you want to get it into decimal mode, you hit the number right over the delete key, the SD button. The SD button, by just touching it once, will change a decimal into a fraction into a decimal, or a decimal into a fraction. So I don't need, this bar means this pattern repeats. It's going to be 15.384615, 384,615, 384,615 forever. Hardly matters. I'm going to round to the nearest person, so I'm going to round to 15 because it's the 0.38's not 0.5 or bigger. I'm going to round, and I'm going to say about 15 people. And all of a sudden, now that I have a rounded answer, it's a little bit harder to check. I could check this number, put it in for x, and it will work perfectly. If I put 15 in for x, it's not going to check perfectly, so I'm just going to even skip checking this and hope that I haven't messed up. But I could check this. I could go 1 over 13 equals 200 over 13 over 200. By checking, I can check the original answer, the right answer, not the rounded answer. Checking that, I would do this. I'd do fraction 200 over 13 over 200. And I'd get a true statement, 1 over 13 equals 1 over 13. So my answer, my non-rounded answer, is absolutely correct. The way my answer could be wrong is if I made the wrong decimal or if I rounded incorrectly. And I made the decimal by using my calculator, so I don't think I messed up there. And you round down, or you don't round up if the number after the decimal is less than 0.5. If it's 0.5 or bigger, you round up. So if this was 15.51, my answer would be about 16 people will have red hair. So that's the first style of problems. Up through 6, probably up through 7, you get that style of problem. The rest of the problems are a little bit trickier. There's 3 styles of problems that come up from the next grouping of problems. And the 3 style of problems, although they're different styles of problems, I'm going to solve them all the same way. So the rest of the section, we have boats problems, and very specifically, the boat problems involve one boat traveling on a river going 2 directions, going with the direction that the river is flowing and going against the direction that the river is flowing. The second kind of problem that comes up after just the easy cross multiplying problems are plane problems. And the plane problems involve one plane going perfectly with the wind, one direction, turning around and going directly against the wind, not doing any kind of crosswind. And then the third kind of problem that we're going to deal with are walker/runner problems. And for every one of these problems, I'm going to take the information and organize it in a box, and that box will help me get my equation, and it'll help me get my answer. Every box that I'm going to do for these three styles of problems is more or less going to look the same. It's going to be the same size. It's going to have a column called distance, a column called rate, a column called time. And in the first column, it's going to have the names of the direction that the boat's going, or the names of the direction that the plane is going, or something to differentiate the walkers or runners in the problem, and that will come up here in a bit. So I made up a few problems that the boxes were given to you, and they're at the end of the section as opposed to at the beginning of the section. I plan on doing all of these, and by the time I get done with these, hopefully you're more or less professional at them and just tired of doing them, and then I'll do the problems that didn't have the given boxes. So the first thing I'm going to do in problem 1, is try to fill in this box that's given to me. So I gave you the box, we might as well use it and see where it takes me. The hard part of any of these problems is going to be the rate box. Rate and speed are interchangeable words. So you can think of this as the speed. And that's going to be where I'm going to need to focus my attention. So as I go through this problem, I see a few numbers along with an answer, which is nice. But I see a boat travels 24 miles upstream against the current. So the first number I see has to do with a distance that the boat is traveling against the current. That 24 I'm going to put in that box because it's 24 miles against the current, and this is the against the current line, this is the distance, and that's exactly what that 24 represents. As I read on, it says, in the same time, it takes a boat to go 48 miles downstream with the current. So the next number I see is the number 48, and that 48 refers to a distance. So it goes in the distance. It's the length of how far the boat went, and it's with the current. So I have two of the three numbers given to me tossed in the box, and that's good. I only have one more number aside from the answer, which generally wouldn't be given to you, and it says the speed of the current is 4 miles per hour. I know because that's a speed, it needs to go in the speed or the rate box, but this is where it gets tricky. So to get the rate done properly, we have to do this. So in boat problems, there's two rate boxes. There's a rate box with the current, there's a rate box against the current, or a speed box with the current, or a speed box against the current. And the speed box with the current is going to be the boat speed plus the current speed. The idea here is if you're traveling with the current, it's going to speed you up. It's kind of like walking on a moving sidewalk going in the direction of the moving sidewalk. The boat speed is the speed of the boat if there wasn't a current. So if a boat was traveling on a lake and turned off that lake onto a river and it's going in the direction of the river, if you don't change your accelerator, you're going to speed up because you'll be going with the river. And for boat problems, the speed box, which is the same as the rate box, against the current is going to be the boat speed without a current minus the current speed. or the current rate, but speed is interchangeable with rate. The idea here is if you were on a flat lake on a boat and you're tooling along at 10 miles per hour, and if you turn onto a river and you're going and the river is flowing against you, the river's going to slow you down by whatever the speed of the river is. So I'm going to go to fill in my rate boxes, and the rate boxes are where the first appearance of a letter, the unknown, is. And very specifically, I'm asked to find the boat speed if there wasn't a current. So my unknown is going to be the boat speed. I'm going to call that B. So what I'm going to do is let B equal the boat speed in still water if it wasn't on a river. I don't know what that number is, but I do know that going with the river, its boat speed is going to be sped up by the speed of the current, and going against the current, the boat's going to be slowed down by the current. I'm basically done. It won't probably feel that way, but if you get this much done with any of the boat problems, plane problems, walking or running problems, you're almost destined to get the right answer. The next thing I'm going to do is get the time boxes. Well, I've used all the numbers. There's only 3 numbers, 24, 48, and 4 in the problem. And I need to get an equation, and I need to get the time boxes filled in. Time boxes are easy. If you look at the numbers, the words here, I see distance, rate, and time. And back in some class, depending on how long ago you had math, you might have remember the formula distance equals rate times time. So for most of us, we get D equals to RT for a formula. This means I can get time by just knowing distance and rate. If I tweak this formula dividing by R on both sides, I get distance over rate equals time. And for every one of the problems that I have a little chart for, a little table, the time box I'm going to get by using the formula time is distance over rate. So for this time box, I'm going to do the distance, 48, over the time, over the rate, B plus 4. For this time box, I'm going to do the distance, 24 miles, over the rate, B minus 4. So I've completely and totally filled in my box. Now I need to come up with an equation. Every single problem in this section, somewheres in the wording, it says that the boats travel for the same amount of time in each direction, or the planes travel for the same amount of time in each direction, or the walking or the running person travel for the same amount of time. Because that little trivial 2 words is included in every problem, the equation that we're going to get is we're just going to set the time boxes equal to each other, because it says the time going with the current is equal to the time going against the current. So once I have the distance and the rate boxes done, time is distance over rate, the times are equal, the algebra I'm going to do is I'm going to set the time boxes equal to, or the time boxes equal to each other, and I'm going to solve by cross multiplying. So I'm basically almost done. I just need to solve for B because I'm just trying to find the boat speed without the current. I'm going to solve by cross multiplying. Let's go no factoring for these word problems. They're actually kind of easy once you get them into equation mode. So I'm going to go 48 times B minus 4 equals to 24 times B plus 4. Clear this fraction, or clear this parentheses. 48 times B is 48B. 48 times 4, I'm doing it off screen on my calculator. 48 times 4 is 192. So just because I didn't feel good about doing 48 times 4, I did it on my calculator. To the right of the equal sign, I'm going to get 24 times B, which is 24B. 24 times 4 is 96. Now I'm going to get the letters on one side, the numbers on the other. I'm going to minus 24b and add 192 to each side. To the left of the equal sign, 48b minus 24b gives me 24b. The 192's cancel on the left side. On the right side, the 24's cancel. And I also have to combine the 96, add the 96 and the 192, and I get 288. To finish up solving, I'm going to divide both sides by 24. On the left side, I get b. On the right side, I have the fraction 288 over 24, and I get 12. That's the answer. I'm going to write the answer with some words. I'll say the boat speed is 12 miles per hour, which is beautiful because that's what I said it was supposed to be. I'm done, but I can check. But the checking only verifies that my algebra was correct. It doesn't mean my equation was correct. So I'm going to go, for checking, I'm going to go, does 48 over 12 plus 4 equal to 24 over 12 minus 4? That's the best I can do for checking, is check each one of these fractions to make sure I haven't messed up. So 48 over 12 plus 4 is 3. Now I'm going to do 24 over 12 minus 4. And I also get 3. So I haven't made an algebra error. So if my table was okay, my equation's okay, then I'm good. And since I had the answer there, I'm feeling pretty good about this. And that makes sense because if the boat speed is 12 miles per hour going with the current, 12 plus 4 is 16 miles per hour. Against the current, 12 minus 4, it's 8 miles per hour. If it travels for 3 hours, which I just figured out, if I take the 12 minus 4, which is 8, times the 3 gives me the 24 miles. 12 plus 4 is 16 miles per hour, times 3 hours gives me the 48 miles, and that works perfectly. But we don't have to get that complex. There's got to be another boat problem coming up. And this is the same style of boat problem. So again, I see it's a boat problem. All boat problems that we're going to do have a boat traveling on with a current and against a current. Every boat problem, I'm going to go downstream, upstream, with current, against current, make a box, and now I'm going to make a column for distance, rate, and time. Those columns, distance, rate, and time, for every single word problem for the rest of the section are going to be the same. The names are going to be different. For the planes and the walking and running problems, the names are going to fit the problems better. But for boat problems, all the boat problems we have is a boat going against the current, a boat going with the current, and so these names will be appropriate for all the boat problems. So now I need to start throwing the numbers in. The first number I see is the number 28. It stands for a distance, so it needs to go in one of the distance boxes. And it stands for a distance going against the current, so I'm going to put it in the bottom distance box. The next number I see is 52 miles with the current. Again, 52 is a distance, and it's a distance with a current, so I'll put it in the other distance box. The only other number I see other than the answer, which I generally wouldn't know, is the speed of the current is 3 miles per hour. That, because it's a speed, it goes in the rate box, or the speed box. And just like the last problem, the rate box is boat speed plus current speed, boat speed minus current speed. I know the current speed, so in for my rate box, I'm going to put the boat speed plus the current speed, and the boat speed minus the current speed, just like I did in the last problem. So every single boat problem, the rate box with the current is boat speed plus current speed. The against the current is boat speed minus current speed. Because this 3 miles per hour represented the current speed, I changed the word current speed to the number 3 in this little template, and I changed the boat speed to the letter B rather than writing out boat speed. So the B stands for the boat speed if there wasn't a current or in still water. That's hopefully, you can see the similarity between this problem and the last problem. Once I get the distance in the rate boxes done, time is distance divided by rate for every word problem I'm going to do for the rest of today. I'm going to take the distance box and the rate box and divide them. And because somewhere in every problem it's going to say they traveled for the same time in each direction, the equation I'm going to get is just setting the time boxes equal to each other, and I'm going to solve by cross multiplying. Because I have an answer staring at me, I don't really need to check, but I can. So I'm going to cross multiply. Doesn't matter which side you do the cross multiplying on. I'm going to get 52 times b minus 3 on one side of the equal sign, and 28 times b plus 3 on the other side. Again, I'm going to pull my calculator out. On the left side, I get a 52b minus, and then 52 times 3 is 156. On the right side, I get 28b, and then 28 times 3 is 84, plus 84. So I cleared the parentheses by multiplying through by 52 and 28. Now I'm going to minus 28b and add 156 to each side. On the left side, I'm just subtract the numbers 52 and 28. I'll be left with 24b. The 156s are going to cancel. The 28b's are going to cancel. On the other side, I need to do 84 and 156, and I get 240. Now I'm going to divide both sides by 24. You can do that without a calculator, but if you can't, you can go 240 over 24 and get the 10. So the boat speed in still water is 10 miles per hour. So my answer is the boat speed is 10 miles per hour. If I wanted to check, I can check that my algebra works. I can go, does 52 over 10 plus 3 equal to 28 over 10 minus 3? And I do each side separately. The left side, 52 over 10 plus 3 is 4, which means the boat is traveling for 4 hours. And then the other side, 28 over 10 minus 3 gives me 4. So that works. And then I can even kind of check more. If I plug a 10 in for the boat speed, 10 minus 3 is 7 miles per hour against the current times the 4 hours. 7 times 4 is 28. 10 plus 3 is 13 miles per hour. 13 times 4, because that's the time. When I do the checking, I get the time. 13 times 4 is the 52. So it works perfectly. 7 miles per hour for 4 hours against the current gives me 28 miles. 13 miles per hour for 4 hours with the current gives me 52 miles. So my answer is checked the best I could check it. The next problem I think is going to be a trick. No, it's not. It's still the same problem. Good. So problem 3, going the same style. It's a boat problem. It would be fantastic if you could do this independent of me. Pause the video, come back, and if you get the 20 miles per hour, just skip through my lecture and move on to the next problem. But if you can't, if you're not ready to do it yet, I'll do it for you here. So boat problem, made the same box for every boat problem. Distance, rate, and time are going to be all the same for every problem I do for the rest of the day. The names are going to fluctuate when I get to plane problems and walking and running problems. So the numbers I see, 36 and 44 represent distance. 36 is the distance against the current. 44 is the distance with the current. I see the speed of the current, speed goes in the rate box. I do boat speed plus current speed, boat speed minus current speed. So with the current, the speed is b plus 2, boat speed plus the speed of the current. Against the current, the speed is b minus 2. Time is distance over rate, so I'm going to go 44 over b plus 2 and 36 over b minus 2. Again, the b is the boat speed that I'm looking for. Time was always distance over rate, so once I put the distance in, got the speed of the current and the speed of the boat in the rate area, I have my time boxes. Because they're traveling for the same amount of time, I can set the time boxes equal to each other. Solve by cross multiplying. One direction of my cross multiplying is going to be 44 times b minus 2. The other direction of my cross multiplying is going to be 36 times b plus 2. This is going to give me 44b minus 88 equals 36b plus 72. I'm going to minus 36b and add 88 to both sides. On the left side, if I can't do 44 minus 36 comfortably in my head, I can use my calculator. I get 8b. The 88s cancel. The 36's cancel on the right side, and 72 plus 88 is 160. So I get 8b equals to 160. I divide by 8. On the left side, I get b. On the right side, I get that 20. 160 over 8 is 20, not that you can see that. So the answer is the boat speed is 20 miles per hour. Again, if I want to check, I can do a lot. For the checking, I'd go 44 over 20 plus 2. Does that equal 36 over 20 minus 2? Check that real quickly. So fraction 40 over 20 plus 2. 44 over 20 plus 2, thank you. 44 over 20 plus 2 tells me the boat's traveling for 2 hours. And the other one, 36 over 20 minus 2, tells me the boat is traveling for 2 hours. So the boat travels for 2 hours. With the current, it goes 22 miles per hour. 20 plus 2 is 22. 22 miles per hour times 2 hours gives me the 44 miles it goes with the current. The 20 minus 2 gives me 18 miles per hour for its speed against the current. 18 miles per hour times 2 hours gives me the 36 miles. So my numbers just fit as well as they can possibly fit. I'm feeling good about the answer of 20 miles per hour. There's the twist. 4 is where if you worked out 4 ahead of me, where you might make a mistake. The big twist in number 4 is the number that's given in the second sentence is not the speed of the current, it's the speed of the boat, and the unknown's the speed of the current. So if you worked this and you didn't wind up getting the speed of the current as 3 miles per hour, the mistake you probably made is in the rate box, because this rate box is going to be backwards. So it's a boat problem. I know that boat problems, I'm given distances with and against the current, and this is even backwards in some sense. The 57 represents with the current distance, and the 39 represents against the current. So the with the current distance, I'm going to put 57 miles. The against the current distance, I'm going to put 39 miles. That part's not the part where you're going to get messed up. The part where you can get messed up is this number 16 that's given is the boat speed. And into the rate, it needs to go before or after the plus sign. And the unknown is the river or current speed. So the big difference between the first 3 problems I did and this problem is very specifically that speed, that 16 miles per hour, didn't represent the speed of the current, so it didn't go in for the current speed. It went in for the boat speed because it represented the speed of the boat. So what I'm trying to find is the speed of the current. And when you're trying to find the speed of the current, then your unknown has to be a letter that stands for the speed of the current, and that's going to be the C. And it has to absolutely be after the plus sign with the current, after the minus sign against the current. So it's always boat speed plus current speed, boat speed minus current speed. And I popped them in there perfectly because the 16 was the boat speed. Once you get the boxes set up okay, the distance and the rate, then the rest is the same. I'm going to go 57 over 16 plus C and 39 over 16 minus C. So the subtle difference in this problem makes the algebra, makes the rate box completely different. And if you don't do it exactly this way, you won't get the speed of the current for 3 miles per hour. So I divided distance divided by rate once I got the boxes, the first column set up okay, and now I'm going to cross multiply and go 57 times 16 minus C, I don't know why I broke out this color, equals 39 times 16 plus C. Absolutely going to use my calculator. So 57 times 16 is 912. So the left side I get 912 minus 57C. The right side, 39 times 16, is 624 plus 39C. Lots of ways to solve this. I'm going to minus 624 and add 57C to both sides. That gives me less negatives than if I would have done something different. When I do that, on the left side, 912 minus 624 gives me 288. I cancel out the C's on the left side. On the right side, I cancel out the 624s, and I get 96C. Now I'm going to divide both sides by 288. I'm going to divide both sides by 96. Oh, stupid. And then 288 divided by 96 is going to give me the 3 on the left side. On the right side, the 96 cancel, and I get C. So the current speed is 3 miles per hour. Again, I could do the checking. If I do 57 over 16 plus 3, does that equal 39 over 16 minus 3? So check it real quickly. Fraction 57 over 16 plus 3 gives me 3 hours for the time. Fraction 39 over 16 minus 3 gives me 3 hours. So the time is 3 hours and the speed of the current is 3 hours. So with the current, it's going 19 miles per hour for 3 hours, and 19 miles per hour times 3 hours gives me the 57 miles. Against the current, it's going 16 minus 3 or 13 miles per hour times 3 hours, and 13 times 3 is 39. If you take 19 times 3, the rate times the time, you get 57. If you take 13 times 3, the rate times the time, you get 39. So the final, the answer is the speed. This computation gives me the time, and speed times time gives me the distance. 5 is just like 4, so hopefully you can muddle through 5 without me. Pause the video. If you get 2 miles per hour for the speed of the current, then you can just kind of go on and not worry about it. But if you don't, then watch my video. So I'm going to fill in the boxes again. The 454 and the 46 are distances. The 54 is with the current. The 46 is against the current. The 25 is a boat speed, not a current speed. So the 25 needs to go where the boat speed goes, not where the current speed goes. The boat speed goes to the left of the signs. The current speed goes after the signs. If you get the right box done, then you'll get the right answer. If you don't get the right box, then getting the right answer is essentially hopeless. Once I get the distance in the right boxes, I divide to get the time boxes. Because the times are equal, I set the time boxes equal to each other. I cross multiply. Clear the parentheses with my calculator handy, because if I try to do those computations without my calculator, I'll probably mess up. Once I clear the parentheses, I need to get the letters on one side, the numbers on the other. I like to deal with positives, so the math that I'm doing is to eliminate as many negatives as I can. I'm not feeling good about this. 4. Really not feeling good about this. If you're following my work, for some reason I changed the 54C on this side to 56C, and that was making bad things happen. So, found my mistake. So I get the current speed is 2 miles per hour. I'm going to skip the checking just to move on to another style of problem. And you can check it the same way. Take your number 2 and plug it in for each of these C's. Make sure each side is the same. When you reduce each side, it gives you the time. Plug the 2 in for this, so it's going 23 miles per hour, 27 miles per hour with the current, 23 miles per hour against the current. I think it's going to be going for 2 hours. So all boat problems fit the same template. The next style of problem that we're looking at are the walking and running problems. They also fit the same template, but it's a different template. The big difference between boat problems and walking and running problems is the rate box. And this is a running problem, but it's not going to be any different than a walking problem. They're interchangeable. For these problems, only one of the rate boxes has a sign. You won't, unlike the boat problems, where one rate box has a plus and the other has a minus sign. So there's a big difference structurally when we're setting up the boxes. In the boat problem, the boat is affected by the river in both directions, so both rates need a sign to give the impact of the river. In a walking and running problem, if you put a sign in each of them, you're going to double the difference in the walker's speed or the runner's speed. So when I go to set up my rate box, I'm going to have to be careful. And very specifically, I'm going to look to the sentence that talks about the speed and figure out what it tells me to do. And in problem 6, the very first sentence is a sentence that talks about the speed. So this sentence is going to help me get the rate box, and only one of the rate boxes is supposed to have a sign. And it very specifically says one person runs 2 miles per hour slower than the other. So to me, slower means minus. And I'm going to put that 2 miles per hour in the slower person's box. So x is going to be the faster person's speed. I don't know what it is, but I know there's a slow person and a fast person. And 2 less than that's going to give me the slow person's speed. If you made the fast person x plus 2, then they're going to be going 4 miles per hour difference. Because like if x was 5, you'd go 5 plus 2 is 7, 5 minus 2 is 3. You'd get the fast person going 7, the slower person going 3, a 4 mile per hour difference, and that's not correct. So the first sentence gave me a comparison of their speeds. It's always going to be the case in my walking and running problem that there's a fast person and a slow person. I named my boxes fast person and slow person. And I'll know their speeds relative to each other. One of their speeds is going to be x, the other is going to have the sign slower. I'm going to subtract from the slower person's. I have the hard part done. Well, most of the hard part. Now I'm going to put the distance in. The faster runner can cover 12 miles, and the same time the other runner can cover 8 miles. So I'm going to think the fast person does 12 miles, the slower person does 8. Now that I have the distance in the rate box, because they're running for the same amount of time, my time boxes are going to be gotten the same way, dividing distance by time. My equation is going to be the same because they're running for the same amount of time. I'm going to set the time boxes equal to each other. I'm going to cross multiply and go 12 times x minus 2 equals 8x. Clear the parentheses. 12x minus 24 equals 8x. I don't like the negatives, but I'm going to deal with the negatives here. I'm going to solve this by minusing 12x. That'll give me minus 24 equals to minus 4x. Divide by minus 4. And I get 6 equals to x. The boat problems I was done because I was only looking for one number, and this because there was only one boat and it only had one speed without the current being factored in. But here I want the speed of each runner. 6 is the faster person's speed, so the fast person is 6 miles per hour. It's probably going for 2 hours to get the 12 miles. The slow person has to run for the same 2 hours, but their speed is 6 minus 2, which is 4 miles per hour. It looks like they're running for 2 miles per 2 hours because 6 miles per hour at 2 hours gives me 12 miles. 4 miles per hour for 2 hours gives me 8. Let me check to make sure my equation is right. I'm going to go 12 over 6 equals to 8 over 6 minus 2. Insulting to do this on my calculator, but I'll do it. 12 over 6 is 2, which is the 2 hours that they're running for. And then 8 over 6 minus 2 gives me the 2 hours. So they're both running for 2 hours. Fast person, 2 hours times 6 miles per hour is 12 miles. Slow person, 2 hours times 4 miles per hour is 8 miles. I feel good about my answer, and it actually matches up there as well. Alright, I'll keep going. I've got a few more of these problems. 7 is a lot like 6. In fact, it's just 6 with the numbers changed a little bit. So first sentence tells me a speed. I'm going to get those rate boxes done. And it's the same first sentence, except I changed the number 2 to 3. So my rate boxes for number 6 and 7 should look a lot alike, except I'll have one number different. So the slow person runs slower than the fast person. I don't know the speed of each, but I know I don't need each to have a sign. I'm going to make x the speed of the fast person and x minus 3 the speed or the rate of the slow. Now that I have the hard part, the rest should be easy. The distances are given in the second sentence. The fast person went 24 miles. The slow person did 15. Time for all of these problems is distance over rate. So 24 over x and 15 over x minus 3. They ran for the same amount of time. So I'm going to set the time boxes equal to each other and cross multiply. There's nicely no factoring. The cross multiplying really makes for reasonably easy algebra. So I'm doing the algebra without explaining what I've done, hoping that you can do it. So after I set the time boxes equal to each other, I cross multiplied each direction, cleared the parentheses that I put around that x minus 3, minus 24x from both sides, divided by negative 9, and I got 8. 8 stands for the fast person speed. So in for my answer, the fast person speed is 8 miles per hour. And then I want the speed of both. The slow person is 3 miles per hour less, so I'm going to go 8 minus 3 and get 5 for the slow. I'm going to check by plugging in 8 for the x's. So I'm going to go 24 over 8. Does that equal 15 over 8 minus 3? This will give me the length of time that they're running for. The 24 over 8 tells me the fast person ran for 3 hours. The 15 over 8 minus 3 tells me the slow person ran for 3 hours. So they ran for 3 hours. If the fast person did 8 miles per hour for 3 hours, there's this 24 miles distance. The slow person ran 5 miles per hour for 3 hours. 5 miles per hour times 3 hours gives me the 15 miles per hour that the slow person ran. So I feel good about my answers. They match up here and they make sense. There's 3 hours at 8 miles per hour, 3 hours at 5 miles per hour. The distances, the whole table just kind of fits together. Oh, I made a biking problem as opposed to a walking problem or a running problem. Biking problems are going to work just like walking, running problems. The first sentence is going to give me the rate box. So here I'm talking about 2 bike riders, a faster and a slower bike rider. So I made my box to have a room for a faster and a slower rider. The first sentence says one person rides 2 miles per hour faster than the other person. What I'm going to do is make my fast person 2 miles per hour more than the slower person. So in this problem, I'm using a plus because plus goes with faster, minus goes with slower. The faster person goes faster, so it needs the extra speed. So I'm going to make x the slow person's speed and x plus 2 the fast person. So immediately you should see a big difference. The biker, walking, running problems, only one of the rate boxes gets a sign. If the word here is slower, the slower person's rate box gets a minus sign. If the word here is faster, the faster person's rate box gets the plus sign. I think for a lot of you, it's going to be intuitive. Now I'm going to put the distances in. The distance are 20 and 24 miles. The fast person travels 24 miles because he's going faster. He's going to go further. The slow person goes 20 miles. Once we get that part, we're done for the most part, because then it's just kind of mindless. I divide to get the time box. I set the boxes equal to each other. And I cross multiply whichever way I care to cross multiply. So divided, distance divided by rate to get time, set the time boxes equal to each other, cross multiply. One direction you get 24 times x, the other direction you get 20 times x plus 2. And then I solve this. None of these require factoring because there aren't any x's, or x squareds. You need to get the x's on one side, the numbers on the other. And then you divide. The bike problems, walking, running problems need two answers. In this particular answer, the 10 stands for the slow person's speed. So when I go to write my answer, I get the slow person is 10 miles per hour because the fast person is 2 miles per hour more. I'm going to add 2 to that 10 and get 12 miles per hour for the fast. I'm going to do my quick check. I'm going to take the number 10 and plug it in for the x's. So I'm going to go 24 over 10 plus 2. Does that equal 20 over 10? Make sure that actually works. So 24 over 10 plus 2 gives me 2 hours. 20 over 10 gives me 2 hours. So they're traveling for 2 hours. The slow person is doing 2 hours at 10 miles per hour. 2 times 10 gives me its 20 miles. The fast person is doing 12 miles per hour for 2 hours, and 2 times 12 gives me the 24. So not only does the algebra check, it makes sense in terms of the problem because I could take this time of 2 hours, multiply it by each of the speeds, and get the distances perfectly. Okay, one more problem that I flat out gave you the box from the extra problems, and then we'll do a few problems that I didn't give you the box, that you're going to have to create the box. So, bike problem. This problem, again, isn't really any different than the problem 8 that we just did, in that in the first sentence, it talks about bike riders and the difference in their speed. The faster one goes 3 miles per hour faster. So in for the faster speed, I'm going to plug x plus 3. The slower person, I'm not going to put x minus 3 because that would make their speeds like 6 miles per hour different. So I'm going to make x equal the speed of the slower person. And x plus 3 is going to be the speed of the faster. I'm going to, now that I have the rate boxes I think correct, I'm going to put the distance boxes in. The distances are 24 and 36. The faster person has to go further in the same amount of time that the slow person goes. Once I have the distance boxes and the rate boxes, I get the time boxes by dividing. And then I set the boxes equal to each other. So hopefully you're getting into somewhat of a groove. This is 9 problems that all, even though they're different, some are boat problems, some are running problems, some are bike problems, hopefully you're getting into some sort of groove, realizing that the rate is the key to everything. If you get the rate box right, everything else kind of comes for free. The distances are given, you divide, you set the equations equal to each other. If you're going to make a mistake, it's getting the wrong rate box. Once you get the time boxes, you cross multiply, you solve, for the x. In the boat problems, one number's enough. In the bike problems, walkers if we had walkers, runners if we had runners, that's not enough to give me one answer because there's two people traveling at different speeds. I did the algebra and got 6. 6 stands for the slow person's speed. So the slow person here is 6 miles per hour. The fast person is 3 miles per hour more. I'm going to add 3 to that 6 and get 9 miles per hour. Now I'm going to check. I'm going to plug 6 in. I'm going to get 36 over 6 plus 3. See if that equals to 24 over 6. Each one of these is going to give me the time. So 36 over 6 plus 3 gives me 4 hours. 24 over 6 gives me 4 hours. So both the fast person and the slow person did 4 hours. The slow person, 4 hours times 6 miles per hour gives me the 24 miles. The fast person, 4 hours times 9 miles per hour gives me 36 miles. So I feel really good that my answers are correct, even though I knew they were correct because they were staring at me. Okay, so now back into the last few problems from the handout. Hopefully you can do problem 8. Problem 10 I haven't touched on a plane problem, but I'll do it. I don't think I've ever put a plane problem on the test, but it's worth watching me do anyways. So no box given to me, so I need to create my own box. That's going to be the case on the test. On the test, you're not going to be given the box that gives you the key to getting the problem done correctly. So as I go through this problem, it's a boat problem, and I know what the boat box looks like. There's one boat traveling on a current on a river in 2 directions. So my box is going to be my standard boat box. I'm going to do a with the current and against the current. Being lazy there, not writing out as much as I typed up. I need a distance, a speed or a rate, and a time. The distances in these boat problems seem to be in the first sentence. 32 and the 8 stand for the distances. So I'm going to put a 32 miles for the distance with the current. 8 miles traveled against the current. I'm looking for the speed of the current, so that's going to be the unknown. And the C goes after the signs in the rate box. So the next number I see is 5. It stands for the boat speed. So I go boat speed plus current speed, boat speed minus current speed to fill in my rate box. Boat problems, each of the rates has a sign. Once I get the rates in, I'm basically done. Again, the reason the 5 went to the left of the sign because the boat speed is first, the current speed is second. The 5 was a boat speed, so I put it where the boat speed goes. Now I'm going to divide. Set the time boxes equal to each other. So I'm going to get 32 over 5 plus C equals 8 over 5 minus C. Cross multiply. 32 times 5 minus C equals to 8 times 5 plus C. Doing 32 times 5 on my calculator. So I get 160 minus 32C equals 40 plus 8C. I'm going to minus 40 and add 32C to both sides. This gives me 120 on the left side equals to 40C on the right side. I'm going to divide both sides by 40. 120 over 40 is 3. And on the right side I get C. That's the only number I need for my answer. The only thing I'm trying to find is the speed of the current. There's not 2 boats, there's not 2 rivers. So the speed of the current is 3 miles per hour. Now I'll doubly check. I'm going to plug 3 in for the original problem. I'm going to go, it does 32 over 5 plus 3 equal to 8 over 5 minus 3. So 32 over 5 plus 3 gives me 4 hours. And 8 over 5 minus 3 also gives me 4 hours. So the boat is traveling for 4 hours. And if I change this to 3, I get 5 plus 3, which is 8 miles per hour for 4 hours, gives me 32 miles. If I change that to 3, I get 5 minus 3 is 2 miles per hour for 4 hours, gives me 8 miles. So with the current, the boat's going 8 miles per hour for 4 hours, it goes 32 miles. Against the current, it's going 2 miles per hour for 4 hours, it's going 8 miles. So I feel really good about that single answer 3. Plane problem. And then a walking running problem. In a plane problem, the wind works like the river. So when I go to do this problem, I'm going to do a box, because for each of the boat problems, plane problems, walking, running, bike problems, I like to make a box. In a plane problem like a boat problem, there's only one plane. I'm only looking for one answer. And I have the freebie boxes, the distance, the rate, and the time boxes. It would be impressive if you could blow through this problem without my help. Like I said, the probability of getting a plane problem on the test is right about 0. I don't think I've ever asked a plane problem on the test because there's just not enough of them in my work for me to test you on them. But I want to push you a little bit, just so you can see a connection here. So for a plane, the rate box is the wind is gonna work like the river. So the rate boxes for plane problems, I have it going with the wind direction, so that I should probably get these in, and against the wind. I started teaching at GCC in '94 and been doing plane problems ever since. Back in the day, in the 90s, students would know that Against the Wind was a song, but I suspect of the 30 of you or so that are watching this video this semester, I don't know, maybe 5 of you know Against the Wind was a Bob Seger song because you're of an age that should know that, but everybody used to. It's amazing how quickly things kind of leave and people don't know anymore. Things that were just common knowledge. So for this problem, the distances are easy. The plane goes 520 miles with the wind and 480 miles against the wind. The rate box with the wind, it's going to be plane speed plus wind speed. And the rate going against the wind is going to be plane speed minus the wind speed. So in this problem, in plane problems, the wind works just like the current, and the plane speed is just like the boat speed in still water. So the number that I'm given in the second sentence, the 250 miles per hour, that would be an insane wind speed, so it stands for the plane speed. And what I'm trying to find is the wind speed. So when I go to plug the 250 into the speed, because it's a speed, it goes in for the plane speed, and the unknown is the wind speed. So in this particular problem, what I'm trying to find is the W, which is the speed of the wind. The numbers get out of control in the plane problems, which is probably part of the reason I don't usually assign them or test on them. Once I get the distance and the rate boxes done, I divide to get the time boxes. The times are equal, so I'm going to solve by setting the time boxes equal. And I'm going to solve by cross multiplying. I'm going to be ultra lazy and I'm not even going to check my answer. Again, I start to fatigue at the end of my lectures, and I just can't even imagine how boring and fatiguing it is to watch these things. So I cross multiplied, absolutely pulling out my calculator for 520 times 250. I get 130,000 minus 520W, and then 480 times 250 is 120,000 plus 480W. So I'm going to minus 120,000. I'm sorry, I'm going to minus 120,000 and add 520W to both sides. When I do that, I get 10,000 on the left side. The W pieces cancel. On the right side, 480 plus 520 is 1,000. So I get 1,000 W. That's a good thing. And then I divide both sides by 1,000. On the left side, 10,000 divided by 1,000 is 10. And on the right side, I get the W. So that's the wind speed. My answer is going to be the wind speed. Is 10 miles per hour. Much better than the 250. Again, if you skipped through that, or if you watched that, I'm happy if you watched. If you didn't watch it, it's not such a big deal. It's just not going to make it onto the test, so it's not such a big deal. What might make it onto the test is problem 12, which is a walking problem as opposed to a running problem or a bike problem. But those are all kind of interchangeable for me, and interchangeable in the sense that only one of the rate boxes gets assigned. So when I go to do problem 10, I have a fast person and a slow person. In this case, they're walking as opposed to biking or running, but it's kind of the same. So I'm being lazy and abbreviating a lot. But it doesn't matter. This is more than enough. So for all my walking, running, bike problems, the first sentence just gets that rate box out of the way. And this is a lot like the bike problems. Only one of the rates gets the sign. And in this case, the faster rate's going to get the sign, and it's going to be 1 miles per hour faster. So in this problem, X is going to be the slow person's speed. And X plus 1 is going to be the fast person's speed. Really, if you just get that done, if you can get the rate box right, everything else is reasonably easy. The distance boxes are given, the time boxes you divide, the equation you set them equal to each other and cross multiply. On the boat problems and in the plane problems, I only need one answer because there's only one plane. On the walking, running, biking problems, there's two people, I need two answers. Put my distances in. The two distances I see are 10 and 12 miles per hour. The fast person does 12, the slow person does 10. I divide to get the times. I set the times equal to each other, so I go 12 over x plus 1 equals 10 over x. Cross multiply, 12 times x equals 10 times x plus 1. So this gives me 12x equals 10x plus 10. I minus 10x from both sides. Gives me 2x equals to 10. Divide both sides by 2. I get x equal to 5. That's one of the two answers I need. X is the slow person speed. So for my answer, the slow person is going to be 5 miles per hour. The fast person is 1 mile per hour greater. So the fast is going to be 6 miles per hour. I'm going to double check. First I'm going to plug in the 5. I'm going to go 12 over 5 plus 1. Does that equal 10 over 5? Both of them are going to give me times. So first one, 12 over 5 plus 1. That gives me 2 hours. And second one, 10 over 5, also gives me 2 hours. So they're traveling for 2 hours. The slow person does 5 miles per hour for 2 hours, which gives me 10 miles. The fast person gives me 6 miles per hour for 2 hours. 6 times 2 is 12. So I feel good about my answers because when I take the time times the rate, I get the distance, and that's what I need to do. I think that's everything I have for you. I know there's a lot less homework problems than there are problems that I did, but you can benefit tremendously from redoing the problems that I did that were in that first 8 or 9 problems of walking, running, biking problems. The first 9 problems that I did, the extra problems, redoing those would be a fantastic thing to do along with all the odd problems in the homework. And if you skip the plain problem, it's just not that. It's not going to impact your ability to do well on the test because there are no plain problems on the test. All right, that's got to be more than enough.